if you're a software developer interviewing right now and you're going through 5, 6, even 7 interview stages just to get rejected at the end of the process, this might be the reason you failed to stand out. After helping over 300 engineers master the technical interview, fast track to senior, and land offers in one of the most competitive software development job markets ever, Bogdan and I detected 5 mistakes developers who failed to stand out make and 5 ways to fix them. And today, we're going to share them with you. Let's start with number 1, implementation focus versus pattern thinking. Bogdan, what does this refer to?
So basically, somebody that is a senior or somebody that will stand out in a technical interview, they will first focus on the pattern or the best practice rather than the code. So imagine, as an example, we're talking about state management in the front end. Somebody very focused on the implementation focus they'll talk about like React context, or maybe they mention something about prop drilling, or say, oh, we were using Redux. Whereas somebody that's thinking about patterns will talk about state management as a pattern. So we say, hey, there's different strategies to handle state in an application. Then they'll go into a client-side application, because again, state is something you have in any kind of application. And then they will talk about, okay, we have components state, we have different levels of granularity, we have global state, or we might have a specific state machine library like Redux, like Redux or Zustand. So they can balance this and they won't go straight to the code, because they know the code can change, the libraries can change, even the domain can change, because again, you can have state in the backend too. But what's important is understanding the pattern behind it.
Because if not, you're just another coder who writes a bit of React, but doesn't really understand what's going on there, how React came to be, right? And how it can be done better. And this is why you don't stand out. You're talking about what everybody talks about. So if you want to stand out, focus on the pattern first, develop this pattern first kind of thinking, and then follow up with the implementation. You need both. Okay, let's move on with number 2, surface knowledge versus technical deep dive. And Bogdan, I think this is very much connected to the first point that we mentioned, this pattern first thinking. But we see the opposite. Coaching developers every day, we see the opposite happening, right? People get into the patterns, get into the best practices, but they cannot go very deep. They end up having this kind of superficial knowledge where they can talk about things, but when you ask them to dive deep in terms of how have you done this, they go blank. Bogdan, how can developers stand out by having this deeper technical knowledge?
Yeah, sure. So I guess the best way to explain this it's again with an example. Somebody with a surface knowledge, let's say the example of web performance in the front end, right? Again, another front end example. Somebody with surface knowledge will tell you, well, the application is slow, so we optimize the images, or we change the fonts, or maybe they even tell you that they run like a lighthouse analysis. They will take it from there, but that will result as a very shallow experience, or they won't really know how the dots connect. Whereas someone that has technical expertise and can deep dive in a topic, they will tell you, well, when you look at web performance, this is what's happening when a page gets interpreted, right? This is our critical rendering path, another pattern. But then they can go deeper and tell you, hey, based on this, the page will be slow because maybe you have too much CSS, or maybe you don't extract critical CSS, or maybe you're not using the right format for the images. You're using PNGs where you should be using WebP. And they would understand why WebP is better. They understand that the WebP image has a better quality to compression ratio because of the algorithm it's using it rather than a PNG, and that it was specifically developed for the web. And so that will come across as an expert because they know things in depth and they can articulate it. They will not just tell you, yeah, like optimize the images, which is very shallow. And people, when they hire a developer, they buy expertise. They are willing to pay a lot more because they don't want to take the risk. And so what happens to a lot of people in interview processes is they go to the end and they don't really know why they got rejected. They just get like a generic email like, we moved one with someone that had more experience. And it's usually because they cannot go deeper in the things they say. They cannot really articulate and really say, hey, this is how it works. This is why. This is like getting to the core of the issue. The reason for it is not usually their fault. It's just at work, you get hanged into so many meetings and they're so easy to procrastinate. And 5 years later, you find yourself in the same position. So you've got to be obsessed with getting to the core of things, getting deep into everything you're working on.
And I would say this is not only for technical interviews in the context of an interview, but if you have your eyes put on a senior level position or a principal level position, you have no choice but to go deep, to develop that technical depth. Awesome. On to number 3, console log versus professional debugging skills. I think this is quite self-explanatory, but Bogdan, what does you've been interviewing developers yourself, you've been interviewing yourselves. What is the advantage of actually learning professional debugging skills, and what are those professional debugging skills versus just console logging the hell out of your code?
So again, it comes down to efficiency, right? Someone that's using console log, they will basically go through the whole code, add console logs. And the other thing is console log works well in the front end, but when you go to the back end, there's so many layers and middlewares that you go through to actually figure out a complex bug. And if you go with console log, I can promise you're going to spend 10 times more time than if you set the debugger up. So what happens is people get these bad habits because everybody's doing it, especially in the front end. We use console log a lot. And then what they see is that the senior person in the team can actually figure out a bug they've been struggling with for 3 days in a couple of hours, or even worse, in half an hour, or even worse, because they know what questions to ask in 5 minutes. Oh yeah, you got to look at that. And so the most predictable way to figure out bugs, and again, software systems are very deterministic. What you put in, you get out. There's no mystery. And so juniors, like they go, you console log, it's kind of very tedious. You need to clean it up. Whereas a senior would go in and be like, okay, let me run through the code with the debugger. There's the front end or the back end. Okay, is there any network layer problem? Then I go in with the network tools. And if not, they use like the back end debugging tools. If it's a database error, they know they can actually create the database manually with a database explorer. And because they have all these tools, they literally see through the code with a crystal clear. They know exactly what the issue is. They know how the system should behave at this layer and why it's not behaving like that. And so they can immediately, like a surgeon, immediately go there and change what's missing. And people see that and they think, wow, it's because of the years of experience or whatever. But the reality is we know people that have 10 years of experience that cannot do that. So it has nothing to do with the years of experience. It's about your knowledge of the tooling. And you really want to be very good at looking at software like with some how would I say this? It's like an X-ray machine in a way. That's what good debugging is. It's really showing you the inner work. And so for a civilian, it looks like they click on something and they get a result. But for someone that knows this, they can see through it. They can see the bones and the tissue and everything that makes up. And it's like blood analysis. All of a sudden, you know what's missing because you did this diagnosis. So get good at debugging. Get good at seeing through the software as it is. The deterministic system where you have function calls and data. And that's pretty much it. It will make you 10 times faster at debugging and fixing problems.
For the people watching us, could you mention just the main tools that you would recommend to a JavaScript engineer that's watching us and wants to get better at debugging?
Sure. So if you're working on the web, starting at a very client-side kind of things, you want to know how to run the debugger in the browser. So go to the source tab, add breakpoints in the browser, and also make sure that you know what source maps are. Because usually when we bundle our code, we'll use the ability to debug that, where you're going to debug some mambo jumbo uglified code that doesn't make any sense. You need source maps. So understand, when do we emit source maps? How are they managed? Once you know that, go back to the network tab in the browser and understand where you are HTTP. So response statuses, response codes, and what are the typical ones? Like what's a 401? What's a 403? What is a 503? What does it mean? Oh, a 503 when you get an error. And also the headers, like what is accepting coding? What is content type? You got to know at least 5 to 10 headers by memory, because that shows that you've been working with them a lot. It doesn't show that you memorize them, but just you know how to get there. Now moving on to the backend, you want to know the debugger tool also in the backend. If you're using TypeScript, it's just VS Code. You can set up the debugger and go with different breakpoints. And then if you're using Docker, or you want to know how to debug inside Docker because it has an extra layer. And finally, in the database layer, you really want to log out, your database calls. And if any database call fails, you're going to be able to copy that query and run it in an isolated environment like pgadmin if you're using Postgres, or you basically want to run the query manually and see why is the query failing. If you have all these layers, you're already 90% there. Of course, there's some more things you could add to the language. If you have that, that's already 80% of everything you need to know.
Awesome. So just to summarize the browser debugging tools, because that's where your code is running, the network tab also in your browser to make sure you understand the different requests. And then inside your IDE, if you're using VS Code, you have a debugger, but most professional IDEs come with a debugger. So learn how to use that, how to set the breakpoints and all that. And later, if you're moving towards Docker, then learn the specifics of Docker, and in terms of database, the specific tooling for databases. I remember back in my junior days when I faced the reality that I had to get better at debugging, and I just didn't want it because I felt like it's going to take a lot of time to learn these tools. They seem pretty complex. And probably that's one of the biggest mistakes I've done. If I would have gotten better faster and I just invest a bit of time in it, the payoff would have been huge later down the road, not only in productivity, but also in standing out in the team as someone who takes their craft seriously. On to number four, vague statements versus knowing your numbers. And we did talk about this surface level knowledge. I think this point is very connected with the other one, but it comes from a different angles. And what do we mean when we say know your numbers in software engineering?
Yeah, sure. So again, the best way to explain this is with an example. Imagine we're talking about testing and we are in an interview setup and I ask you, hi, do you test your code? Do you write tests? Somebody giving a vague answer would say, yeah, we do. We write unit tests. That's it. But someone that knows their numbers would talk about code coverage. And we talk about how at the moment, let's say we have around a 50% code coverage, but we're working towards getting it at 70%, knowing that, for example, Google will not approve a pull request if it has less than 65% code coverage. So they can always reference what they do back to an industry best practice. It doesn't mean they will always apply the best practice. You don't have to. You don't have to work like Google if you're not Google, but they do know those references. Another example would be, for example, loading time, right? So somebody with experience would know that if you ship more than 1 megabyte of JavaScript in a single bundle, there's a big issue going on there. Like if you're really downloading a single bundle and they know how to find this out, go to the network tab and look at it and be like, okay, 1 megabyte, it's way too much. The industry standard, like the Webpack warnings, trigger already at 250 kilobytes after you compress and minify. And so because they have these references, they can give an expert insight when they're being asked a question. And they're going to tell you, yeah, just make sure your bundle is not too big. What do you mean? What is it too big? What is it too slow? What is a slow request? And then they can bring that into their context. So it's not like somebody that just talks about, yeah, we should do code coverage of 65% because Google does it. And they say, look, industry best practices here. This is our context. How do we combine that? And that gives this flavor of, okay, this is an expert. This is a person that has expert decision making. They know the industry numbers and they can bring that into my business. And it just shows professional etiquette and it will make them go crazy. It will make them even throw more money at the table if they found someone like that. Those people do not come along very often. And that's kind of combining that hands-on thing with the engineering mindset.
Very important, as Bogdan said, to know your numbers and also the why behind them. So those are not arbitrary numbers that you found on the internet or because Google says so or Meta says so, but you know the reasoning behind those numbers. And knowing your numbers will allow you to do something that's crucial to any job in the 21st century, which is making data-driven decisions. As a software engineer, you have to make tons of decisions, not only technical decisions, but also user experience focused decisions. So knowing your numbers, knowing how to interpret data, knowing how to find the data will definitely allow you to stand out. And this is an easy one because most developers out there don't. Trust me, I talk to hundreds of developers every day and most developers can't tell you why, most developers cannot tell you what's their code coverage and why it's, 65, why it's not 85. Okay, moving on to final point, number 5, code versus systems. Bogdan, what does it mean to focus on code versus systems or to focus on systems versus code?
So most of us work on coding 80% of the time, right? We build components or API endpoints. But at any point, everything you do, you need to reflect that on top of the overall system. So a lot of people struggle when they need to look for a new job because usually there's a lot of red taping in your company. So only seniors touch the pipeline or only seniors touch the Webpack configuration or the tooling or only seniors decide how we're going to organize our Git branches. And what happens is then you go out and people at senior level, they expect you to have an opinion on that. They expect you to know. They expect you to know how to set up a pipeline. They expect you to know what microservices are. They expect you to know how to, how to make decisions by yourself. That's actually a senior. They don't need help. They can reflect. They can make their own choices, correct their own work, and deliver. And so you need to always bring it back to systems thinking. You need to always ask yourself, okay, I'm working on the front end. What's the back end? What's the API? Okay, what databases they use? We're using Mongo. Okay, that's a NoSQL database. Why are we not using a relational one? Even if you're working on the front end, you always want to reflect your choices based on the whole system. That's what we call system thinking. And you understand that even if right now, for the last 2 years, I've been working on this component, if I need to work on the other one, I know how these parts relate. They can talk about architecture, they can talk about deployment. If not, you're just a component developer or endpoint developer, and that's a very low paid, very poor added value position. You won't be able to show a lot in interviews. You'll feel very weak, and there's so many black boxes around you don't really understand. And that's okay. We all start out that way, but you really need to start working your way out of it. And it's really important that you need to do it. Your company will not give you the responsibility most times if you don't already know how to do it, because they don't want to take the risk, because you'll make mistakes and they will pay for it. And so you need to be proactive and try to go out, take more and more responsibility and expand your view. Don't just be like a component developer or like a backend API developer.
So folks, it's about getting into the big picture as well, not only the code, even if most of your time you see only the code, not what happens after. Now, Bogdan, when we talk about systems, right, what would be an immediate step? What would be 2-3 things that a developer could look into by themselves in order to take that step and to become a more systems-oriented person and develop this big picture view? What are we talking about?
So if you're working right now in a company, and you're working only on the front end, try to also run the back end. Just pull the code, pull the repo, run the commands. They are in the README. If you don't understand it, ask for help, but just try to run it. Try to see, okay, can I run the API? And can I change endpoints? And can I fetch those endpoints from the front end? Just a very like a hello world. As long as you go out of like just the front end, it will already change your view. Try to run the pipeline. Try to see how they define the pipeline. What are the different stages? How does it break? Can you roll back by yourself a failed deployment? You don't need to be a DevOps expert to do all those things. You just need to be onboarded on that system. And if you run into blockers and you're at your job, try to figure out if someone can help you. Okay, to help you build. It's an excuse to reach out to people outside of your team. And if you have to put 1 or 2 extra hours so that this in your learning time, that's okay. Trust me, it will pay back a lot. A lot of the people are just in the developer treadmill. They get tickets and they try to solve those very fast. And 4 years later, they can only get mid-level jobs because they only know, to talk about the tickets they solved in a sprint. If you're interviewing, so let's say you're not having a job right now, you're interviewing, take one of those drawing software. I use Steel Draw for the most part. Map out your current, the architecture in your last position. How did it look like? Even the parts you don't know. And then map out the CI/CD process. If you don't know it, just try to map it out hypothetically, but have an opinion about it. Then just go in there and talk about the tickets you solved in a sprint. Nobody cares. They can't even understand them because that's very specific to your company. So you need to pull yourself out and try to see, the architecture, the CI/CD process, both if you're working right now or if you're going to be in there.
Awesome, Bogdan. So map out your deployment process and map out the architecture and get your hands dirty. Get out of your IDE, get out of your React, get out of your Vue, and go out there and get your hands dirty with other pieces of the system. And don't expect your company to do it for you. Well, folks, this has been for today. Knowing these 5 things will definitely help you stand out in technical interviews. And not only that, but also develop a senior level engineering mindset, which will get you one step closer to the next level. Now, mindset alone, it's not enough to pass a technical interview. So make sure you also check out this playlist where we go a lot deeper in tons of very common interview questions and this next video. As for Bogdan and I, Bogdan, thank you so much. We will see you in the next one.